Hey guys, I hope you're all doing well. Just wanted to go over this review that I gave you guys today and just kind of go through each question and run through them to make sure that you guys know how to do these. Remember, today's going to be our last review day, so if you guys have any questions at all, just make sure you reach out to me or you can join that Google Meet session too, and we'll be able to figure out any questions that you might have. All right, so let's start with these first problems. Now, on the first problems, I told you guys to just only pick 6 out of the first 9. You don't have to do all 9, but I would definitely suggest looking at a problem like number 9 because you're probably going to see one like that on the quiz tomorrow. All right, so I'm going to run through all of these, even though you guys only have to do 6. All right, so first one, let's look at number 1 first. So you have the third root of x minus 3 plus 2 is equal to 4. So the first thing that you guys want to do is you always want to try to get that root symbol by itself. So we're going to go ahead and subtract 2 on both sides. All right. So now that we have that third root by itself on that left side, this is when we want to get rid of it by now raising this to the third power because those are going to offset. But whatever we do to the left side, we do to the right side. So by raising it to the third power, we get rid of that root symbol and we just have an x minus 3. And we know 2 to the third ends up giving us 8. All right, so then in order to solve for x, you just add 3 to both sides, and we get x is equal to 11. All right, so when you look at number 2, number 2 is really similar. It might actually be even a little bit easier because when you look at number 2, you have the square root of 3x plus 10 is equal to 8. So that root is already by itself on the left-hand side. So all we have to do is try to get rid of it. And we know to get rid of, in this case, a square root, all we're going to do is square it. So we're going to raise the left side of the second power, which means we just have to raise the right side of the second power as well. So your radical symbol is going to cancel out. So you just have your 3x plus 10. Sorry, that was a plus sign. And then we know 8 squared is 64. And then we want to go through and just solve for x, just kind of like we normally would. So we're going to first subtract 10. And then divide by 3. All right. All right, now remember one thing that we talked about before is you guys always want to check for these extraneous solutions, especially when you're squaring both sides of an equation. So like on number 2, we had to square both sides to get the answer. So all we want to do is take that 18 and plug it back into our original equation for x just to make sure that it still does work out. So in this case, when we go through and we plug back in, we're going to end up getting the square root of 64 is equal to 8, which we know is true. So x is equal to 18 is going to be one of our answers, or our only final answer. All right, let's look at 3. So when you guys look at 3, really similar to like we just talked about, you want to try to get that, in this case, that square root by itself. So the first thing that we're going to do is we are going to subtract an 11 on both sides. So when we do that, we end up getting the square root of 9x is equal to 3. All right, at this point, this is when we want to get the square root away. So we are going to have to square both sides. So that's going to leave us with a 9x is equal to 9. At this point, let's divide by 9 to solve for x, and we end up getting that x is equal to 1. And again, since we did end up squaring both sides, just check for those extraneous solutions. But when we plug in a 1 for x, the left side definitely equals the right side, so we're okay. So x is just equal to 1 in that case. All right, when you guys look at 4. Now, same thing that we've been talking about on these other 3 problems applies to 4. It's just you're going to have to take maybe 2 steps to get that radical symbol by itself instead of just 1. Because in this case, you see a minus 4 right in front or a negative 4 out in front and a plus 3 from behind it. So we want to try to get the third root of x plus 10 by itself. So the first thing that we're going to do, just like we would do in a normal equation, is you want to subtract 3 on both sides. So we're going to have negative 4 times the third root of x plus 10. And we subtract 3 to get a 12 on that right side. Now, once you're here, now we can go through and we can divide by that negative 4. But save that division till last. So that'll give you the third root of x plus 10. And that's equal to 3. All right, so now once we're here, now we can go through and try to get rid of that radical symbol by taking a look at that index number, which is a 3 because we're dealing with the third root. So we're going to have to raise it to the third power. And that means we'd have to raise to the right side to the third power too. So on our left side, we're just going to have an x plus 10. And 3 to the third is 27. All right, last step you guys are going to take. Oh, I'm sorry. I was just looking back and I realized I totally forgot a sign, which should make this a big issue. Back at this step, when you went and divided a negative 4 on both sides, I'm sorry, this should be a negative 3. So it's negative 3 to the third, which gives us a negative 27. I'm sorry, I just skipped that negative sign. All right, now last step to get x by itself is subtracting a 10 on both sides. So we end up getting x is equal to negative 37. And that's our final answer. All right, so when you guys get to problems number 5 and 6, obviously we're starting to work with those exponents that are now fractions. So we're going to have to kind of think about how we're going to get rid of those. But the same thing that we talked about on those first 4 problems still apply. Like on the first 4, we said we want to get the radical by itself before we do anything. Same thing on 5 and 6. You want to get whatever is being raised to that exponent by itself before you try to get rid of it. So like for example, like on number 5, in this problem, the only thing being raised to the 3/5 is x. So you have to first divide by a 9 on both sides. So that would give you x to your 3/5 is equal to 8. All right. Okay, now when you're here, if you guys remember when we start working with these exponents that are fractions, we have to try to get rid of them by multiplying by something. And when we multiply a fraction by its reciprocal, it just gives us 1, which is exactly what we want because we know something to the first power is just itself. So when we multiply the 3/5 by 5/3, that's going to end up giving us on the left side just an x to the first, which we know is really just an x. All right, so be careful when you do this to the left side. Remember, you're not multiplying 5/3 by 8. You're multiplying the 5/3 by the exponent of 8, which is really a 1. So you're going to multiply this 1 by 5/3, which then means that we're going to have x is equal to 8 to the 5/3. All right, now when you guys have a problem like this, don't leave that as your final answer. You want to simplify it as much as you can. So when we have a base number being raised to a fractional exponent, remember we can rewrite this in radical notation. So we can take that denominator, make that your index number, and then all raise it to that power of the numerator. So we're going to have the third root of 8 all to the 5th power. And then we know the third root of 8 is 2. 2 to the 5th actually ends up giving us 32. So make sure you guys just take that additional step at the end. Don't leave that as 8 to the 5/3. All right, now when you guys get to number 6, really, really similar. The only thing is the thing that's being raised to the 7/3 now is this entire 3x plus 5. That's being raised to the 7/3. So that means that we just have to subtract the 22 on both sides. So you're still going to have this 3x plus 5. to the 7/3. And that's going to be equal to 128. All right, now this whole entire group, like we said at the start, is being raised to that 7/3 power. So now once you have that on the left side, now you can look to get rid of it. So that means we're going to multiply the exponent by 3/7. And that means that we're going to also multiply the exponent of 128, which is 1, by 3/7. So then when we do that, the left side is just going to be 3x plus 5. And the right side is going to be 128 to the 3/7. All right. All right, now your job is still to solve for x, right? So you still want to eventually subtract 5 and divide by 3, but you can't do that until you simplify this right side over here. So we're going to simplify this the same way that we did our last problem, where we're going to rewrite it in that radical notation and have the 7th root of 128. That's all going to be raised to the 3rd. All right. Now once you guys are here, you have to simplify that right side like we talked about. So the 7th root of 128 is actually 2. And then 2 to the 3rd would give us 8. So that means that we're going to have 3x plus 5 is equal to 8. I'm just going to draw a little arrow. I'm kind of running out of room. All right, so now that you're here, this is when you want to go through and solve this like you normally would. So let's subtract 5 on both sides and get 3x is equal to 3. And then divide by 3 and get x is equal to 1. And that one would be your final answer. All right, so let's look at 7 and 8. Okay, so 7 and 8 go back to the radicals. All right, so when you look at problem number 7, you have x minus 6 is equal to the square root of 3x. Now, we talked about on the first problems always getting the square root by itself. So on number 7, the square root already is by itself on that right side. So we want to get rid of it by squaring it. But whatever we do to one side, we know we have to do to the other. Here's where you guys view that video from before. And just be careful about when you're squaring, especially x minus 6. Remember, when we square something, that really means that we have 2 of them. So we really are what we're saying is that we have an x minus 6 and an x minus 6, which tells us that we're going to have to FOIL. Make sure you're not just distributing the squared in there and getting x squared minus or plus 36. So once we have something squared and we write it out twice and we FOIL like we talked about, that's going to make this problem look a lot different. We have x squared. Combining my outside and inside terms, I end up getting a minus 12x and then a plus 36. All right, now from there, you just need to solve that equation, which means you're probably going to have to set this entire equation equal to 0 and try to factor because we see that x squared and x to the first in there. So I'm just going to subtract the 3x on both sides. And then I need to find my factors of 36 to give me 15, which are going to be 12 and 3. And they're both going to be negative. All right. And then when we go through and solve each of these two groups for x, we're going to end up getting x is equal to a positive 12 and a positive 3. All right, now like we talked about before, just make sure, especially on this problem, since you are squaring both sides, make sure that you guys are checking for those extraneous solutions. So in this case, when we go through and plug 12 in, 12 is definitely going to work. You end up getting 6 is equal to the square root of 36. But when you plug 3 in, 3 does not work because 3 minus 6 on that left side of the equal sign is negative 3. And you have negative 3 is equal to the square root of 9. So 3 will not work, which means our only answer for this problem is x is equal to 12. All right, let's look at 8. So on 8, you have the third root of 12x minus 5 is equal to the third root of x plus 15. So if you guys remember the notes, I said anytime that you have like a square root equaling a square root, or a third root equaling a third root, or it could be like a sixth root equaling a sixth root. As long as everything is underneath the square root symbols, these are going to be your easiest types of problems. Because if you think, well, if I need to get rid of a third root, I need to raise it to a third power. And whatever I do to one side, I just have to do to the other. And when we raise both sides to a third power, well, the radical symbol then just drops off. So then the left side, you just have 12x minus 5. And the right side, we have 8x plus 15. All right, and then from there, it's just a normal equation that you guys want to solve by getting your x's to one side and your numbers to the other. So if we subtract an 8x on both sides, I get 4x. If we add a 5 to both sides, this right side's going to now give me 20. And then when I go through and solve for x by dividing by a 4, it's going to give me x is equal to a positive 5. All right, so let's move on to 9, which might be a little bit more challenging than the rest of them. All right, so moving on to number 9. So when we take a look at number 9, the reason why number 9 is a little bit tougher than the other problems we've seen, especially like referring back to like number 8, is because now if you look at the left side of this equation, you see that plus 2 right there. And that plus 2 is outside of that square root symbol. So that's what makes this a little bit harder compared to a problem like number 8. So what you guys want to do is you want to first start off by squaring both sides. The reason why we do that is because this right side has a square already by itself. So I definitely want to square that side, which means that I would then have to square my entire left side. Now, remember, like what we talked about before, is when you're squaring a side, it really means that you have 2 of them, right? So I'm actually going to go through and I'm going to write this out twice. So I'm going to have the square root of 2x plus 3 plus 2 times the square root of 2x plus 3 plus 2. And when I square that right side, that's just going to give me a 6x plus 7. Okay. All right. So the reason why I'm writing that out twice to really show you guys this is because now this left side here, you're going to have to try to FOIL. Because what you're thinking about is you're thinking about your square root of 2x plus 3's. Those are like your first terms. But then the 2's at the end, those are your second terms. So when we go through and we FOIL this, and I'll do this step in green. So if we think about our first, the square root of 2x plus 3 times the square root of 2x plus 3 is just going to give you 2x plus 3. Now, when we go to our outside and have the square root of 2x plus 3 times 2, that 2 is just going to go right out in front. So you're going to have 2 times the square root of 2x plus 3. Same thing with your inside. You're going to multiply 2 times the other square root of 2x plus 3, which gives you 2 times 2x plus 3. And then your last, that's probably the easiest one. You just have 2 times 2, which is going to give you 4. I think that foiling part is the toughest part. Just be really careful with your outside and inside terms and everything like that. So now once you guys are at this step, this looks really confusing, but you just want to try to condense the left side of that equal sign first. it'll make it a lot easier to kind of look at. So what we mean by condensing is combining like terms. You can't combine anything with the 2x, so that's going to drop down. The 3 and the 4 can definitely add together to give us a 7. And if you guys remember adding square roots, we can also add these two inside terms together because what's underneath the square root is exactly the same. And when they are exactly the same, all we have to do is add our coefficients. So we're just going to add 2 and 2 together to get 4. And then that 2x plus 3 is just going to stay underneath the inside. And then the right side is not changing. All right, so once you're here, now what you guys want to do is you want to try to get that square root of 2x plus 3 by itself. So in order to get that by itself, what that means is I'm just going to have to take this 2x and this positive 7 and subtract them to that right side. At least that's my first step. So that's going to end up giving me 4 times 2x plus 3. Times the square root of 2x plus 3 is equal to 4x. And then the 7's just canceled out. So you actually just end up having 4x. Now to get that square root by itself, you have to divide by 4. So that's going to give us the square root of 2x plus 3 is equal to just 1x, which we'll just write as x. All right, now that you guys finally have that square root by itself, now this is where you want to actually now be able to square both sides to get rid of it. So that means when I square both sides, my square root symbol is going to cancel out, but this x is now going to become an x squared. So you know what? I'm going to do it over here. Okay, so that's going to end up giving us 2x plus 3 is equal to an x squared. And then once we have this, now that we see x's and x squareds, let's move everything to one side by keeping that x squared positive. And then we're just going to have to try to factor and then solve it. So then when we solve this for x, we end up getting x is equal to a positive 3 and a negative 1. Just be careful before you're done this problem, though. Remember, check for those extraneous solutions because you did have to square both sides, both the start of this problem and then kind of in the middle. In this case, negative 1 does not work, and the only solution that works is a positive 3. So x would just be equal to positive 3. All right. Okay, I did tell you guys you didn't have to do number 10. You could have skipped it. If you wanted to do number 10, though, just to go over this really quickly, checking that mistake is actually made in this first step right here. You're not allowed to right away take the third root of both sides. What you have to do first, you can't raise it to the third power. What you would have to do first is you would have to get rid of that 2 by subtracting 2 on both sides to get the third root of x by itself. Once you have the third root of x by itself, then you could raise both sides to the third power. So if you are doing this problem, just wanted to give you guys the answer once you fix that mistake. The answer to number 10 would be x is equal to 8 if you wanted it. But again, you guys don't have to do that problem, but it wouldn't hurt. All right, so then the last few problems that we were going to go over are our radical functions and how to graph these. All right, so if you guys remember, whenever we graph these radical functions, we always have like that one starting point, and then we use a number in front of our square root to get our second point. And you only need 2 points for these graphs. So like if you look at number 11, when we think about like getting our starting point, you always have your x value of whatever's opposite of the inside. So we're going to start with a negative 3, and then you always take whatever value is at the very end. Now in this case, if nothing's there, your y value is going to be 0. So that tells you guys that you just go to the left 3, and there's your first point. Now when you look at your number out in front of your radical being a negative 2, it's really a negative 2 over 1 because we treat it like slope. So what that tells us is from that one point that we already have plotted, we're going to go down 2, and we always run to the right. So we're going to go down 2, we're going to go to the right 1, we're starting there, and we're just kind of curving this off until it levels out to the right. If you look at number 12, first thing is get your starting point. So if we look at the opposite of the inside, it's going to be a positive 4. The same side as my outside. In this case, it's going to be a negative 2. So that tells us that we're going to go 4 to the right, and then we're going to go down 2. And that's going to be our first point. Now, in this case, when we look out in front, we know we don't really see a number. Oops, sorry. But when you don't see a number, that's really a 1. So that tells me from that 1 point, I'm going to go up 1 and to the right 1, make that second point, and then just form that curve going off to the right. Okay, last two we're going to go over are 13 and 14. All right, so when you guys are looking at number 13, same thing, get your starting point. But in this case, it's a little different because nothing's with x under the radical. If you don't see anything plus or minus with x, your x value is just going to be 0. Your y value is going to be a negative 4. So that means that we're going to go down 4, and that's going to be our first point. My value, my number out in front of that radical is 3, so it tells me that I'm going to have to run up 3 units and to the right 1, which just stretches this out vertically. And there's my second point. So then I connect my 2 points and then just go off to the right. All right, last one, number 14. When you go through and you get your starting point, opposite of the inside is going to be a negative 1. The same side of your outside is going to be a positive 3. So I go to the left 1 and I go up 3. Sorry, I know this isn't very neat. So then when we look at this value out in front of negative 3, that means I'm going to go down 3. I'm going to go to the right 1. There's my second point. I connect those 2 points, level this thing off as it goes over to the right. All right, so if you guys have any questions on any of these problems at all after viewing this video and looking at that answer key, please let me know. Join that Google Meet session, and make sure you guys study and prepare yourselves for tomorrow's quiz. All right, have a good day, guys. I'll see you later.